compound inequality is when you have two inequalities kind of mushed into the same problem. So we're going to graph them on the same number line, but usually there was just one dot and one shading. So because we're having two solutions here that we're showing, we're going to put them on the same graph, so you're going to have two important dots and shading. So you're either going to shade in the middle between the 2 points or towards the outsides. Now, you're going to have and or type compound inequalities. So and, you won't even see the word and. I'll show you what that looks like in a second. But those are the ones where you're going to shade in the middle between the points. And then or, you shade towards the outsides. So you usually will see the word or. And the way I remember that is like they both start with or, outside, and middle. So if you look, if you had the inequality x is greater than or equal to 5 and x is less than 7, here's how you rewrite that as a compound inequality. You mush it all into one, but there's two different inequality signs. So the left side here you'll see is the negative 5 is less than or equal to x is the x is greater than or equal to negative 5, and the x is less than 7 is represented over here, less than or equal to. So the way I remember these kind of problems is if your variable's in the middle, you shade in the middle. So again, they don't usually say the word and with the and type compound inequalities, but you do see the word or when it is an or. Write a compound inequality that represents each situation and graph the solutions. All real numbers that are at least 2 and at most 4. So if it was at least 2, negative 2, that would have to be greater than or equal to negative 2. At most 4 would have to be less than or equal to 4. Now if we were to mush this together, obviously negative 2 is the smaller. So it would say negative 2 is less than or equal to x, which is less than or equal to 4. The arrows always face the same way with a compound inequality. Now as far as the graphing, let me move over here. Now which one is lower? Negative 2 is lower. So that would go on the left side here, and positive 4. Now, don't write what I'm about to write yet. But if you were just graphing this left portion, that would be a solid dot on negative 2, and it would be shading everything to the right. Now the 4 would be a solid dot on 4, and it would be shading everything to the left because it's less than that. So the reason we shade in the middle is because that's the only area where they would overlap each other. But again, once you kind of get used to the rule, if it's an and inequality, you shade in the middle. If it's or, you shade towards the outsides. Today's temperatures will be above 32 degrees Fahrenheit, but not as high as 40. So it's going to be between 32 and 40. Now let's figure out the inequalities. It's going to be above 32, so it's not going to include 32. But not as high as 40, so it's got to be less than 40. And it says less than, not as high as 40, so it's not including 40. Now if we were to throw this on there with a 32, with a 40, these are both less than inequalities, so they would both be open dots because those numbers are not included in the solution. And between 32 and 40, you would just shade in the middle. That includes 33, it includes 39.842. All those numbers are included in those solutions. Now, if you see the word inclusive, which I'm really surprised they throw big words at us like that, that is the or equal to's. So all real numbers greater than negative 2, but less than 9. We have to graph these as well. So greater than negative 2, but less than 9. 2, 9. These are both open dots, and we would shade in the middle. Part B, the books were priced between $3.50 and $6, inclusive. That just means the or equal to's. So we have $3.50 less than or equal to X, less than or equal to $6. So the prices fall between and including $3.50 and $6. $3.50, $6. It includes those, so it has the solid dots. And then this is an and problem, so it would be everything between those 2 points as well. All right. Now this is written as an and problem because the inequalities are going the same direction, your variable's in the middle. You can solve this as 2 different inequalities if you want, that one and this one, but you can really just solve them all at the same time. If you didn't have the left side of this and you just had r minus 5 is less than or equal to -1, you would add 5 to both sides. And that's true, but we're just going to add it to all 3 parts here. -4 plus 5 is 1. In the middle, the -5 plus 5 cancels, so we just have r. And then over here, -1 plus 5 is 4. Great. That's pretty easy. So 1, 4. Now on the 1, it's an open dot because you have the less than. On the 4, it's got the or equal to's, so that would be a solid dot. Then the r's in the middle, it's a shade in the middle. Too easy. Too easy. Let's try C, and then I want you to try A and B. So we have a 2-stepper here. But again, ignore the left side of it. If you had -3n plus 1 is less than or equal to 13, first you would subtract the 1. So we're just going to do that to all the parts. 6 is less than -3n is less than or equal to 12. And then we have to divide by that -3. What's important to remember, if you divide by a negative, you need to flip the inequalities. So -2 is now greater than n, greater than or equal to -4. Ooh, this changes things. Because if this was a real number line, -4 would be less than -2. So some kids like to just, they're like, I see the number -2 first, I'll write it on the left, and -4 second, I'll write it on the right. But you have to think if this was actually a real number line, -4 would be on the left of -2. So -4 gets the solid dot. -2 just gets the open dot. This is an and problem, so you shade in the middle. So try these out, give them a whirl, and check in. So, all right, here we go. Divide by 3. 2 less than or equal to x less than 5. 2, 5. Here we will add 1. 2 less than 2x less than 8. And then we'll go ahead and divide everything by 2. -1 is less than x is less than 4. 1, 4, open dots on both of them, shade in the middle. Now we're going to try some OR problems. Write a compound inequality that represents each situation and graph the solutions. All real numbers that are less than -3 or greater than 7. Now there's no overlap there. You can't have a number that's less than -3 and also greater than 7. That's not possible. So even if it didn't say the word or, we know that this is an or problem because they don't have anything in common. So x is less than -3 or x is greater than 7. You just write it like that. You don't mush it in as one inequality like we did with the and problems. Keep the word or. If this was real, we'd have -3 over here, we'd have 7 here. On -3, it'd be an open dot shade left. So those are all less than -3. Greater than 7 would be an open dot shade to the right. But again, if you remember or problems outside, you always shade outside on or. Discounted fares are available to children 12 and under or to adults at least 60 years of age. So 12 and under could include 12, but everything less than 12 as well. Or the adults, it says at least, that would be greater than or equal to 60. Now this, of course, has realistic limits because you're not going to have children negative 5 years old. So I guess that would go to 0. Also, you're probably not going to live to 200 years old. So there would be a realistic limit over there. But yeah, let's be realistic. Let's go to 0. So we'll mark 0, 12, and 60 on this one. Why not? So the 12 includes it, but also less than that. I'll have it go to 0, but an open dot, because they're probably not going to be being born and also getting on the bus at the same time, right? So it's going to have to be greater than 0. They're going to have to be at least 1 second old to get on this bus or plane. I don't know what it's talking about here. And then 60 plus. They might live forever. Who knows? We don't know how old they'll be. All right. Write an inequality that represents all real numbers that are at most negative 5. So at most would have to be less than or equal to negative 5, or at least 3. That would include 3. Graph your solutions. So we have negative 5, we have positive 3. These are both closed dots, and it says or, so that's outside. Or you can just graph them individually. Less than negative 5 would be to the left, greater than positive 3 would be to the right. But it'll become shorthand, you'll know or outsides. And this is it. Ooh, a little bit tougher. Now these are just 2-steppers, but it says the word or in the middle, so we know we're going to shade towards the outside. 4b plus 3 is less than negative 5, subtract 3. 4b is less than negative 2, divide by that 4. And negative 2/4 would reduce to negative 1/2. Over here, we would subtract the 7 first. Negative 2v is less than negative 6. Then we have to divide by that negative 2. Remember to flip the sign. V is greater than 3. There's a 4 there, so we're going to be shading outside. Now, realistic number line, we'd have negative 1/2 or negative 0.5. We'd have positive 3. We have me out of the way. On negative 1/2, open dot, and left, open dot, left. On positive 3, also open dot, and to the right. You got to remember the rules with the dots and the shading to be able to do this. So I'd like you to try this out. Pause it, try it, see how you do, check in. All right, -7. Ooh, we're going to have to flip the sign here. X is less than 2. Here we don't. X is greater than or equal to 3. Alright. 2, 3. On 2, we have an open dot left. On 3, it'll be a closed dot. And to the right, we did it. Compound inequalities. Yes!